Okay guys, welcome back, and you have made it to the end of the No BS Java Spring Boot course. Congratulations. Have we covered every single thing you could possibly do? No, of course not. But you are now fully rounded, and I believe you are ready to get a job as a junior backend engineer. Congratulations. Now I do have a final exam for you. This is going to encapsulate probably 90% of the topics we've covered. And here it is. I strongly recommend that you try to do this yourself without me. So listen to my requirements, then go do it, and then come back if you get stuck. This is really important. This is how you actually learn, not just being spoon-fed stuff. Go out there, make mistakes, and fail, and you'll learn a lot more. Okay, so the business came to us and they said they want the ability to create, read, update, and delete a product. So this is an Amazon backend type of application. So the product, they want it to have an ID, a name, a description, a price. Now they didn't tell us what the ID had to be. Is it going to be an integer? Is it going to be a GUID? We don't know. You have to decide that. The end customer doesn't care, right? It needs to have a category, and they want a set of categories that they can update after we've already deployed. So what that means is this is going to live in a table in SQL, and we're going to have a many-to-one mapping where many products can map to a single category, right? And then if they have a new category down the line, say 3 months, they can just update this table and the whole application will still work. We don't have to redeploy or change any code. They want a timestamp created for record keeping. They want timestamp updated. When was it last updated? They want a region. Right now, they just want US and Canada, and they're not going to change that for a very long time. That tells us something different, right? We're not going to put this one in a table. We're going to have an enumeration, an enum in Java that's either US or Canada, and we're going to just save that directly to our product table. And then they want a manufacturer. Okay. Now, they didn't talk about required fields or minimum lengths, right? Obviously, ID is required. Name should be required. Is description required? Maybe you decide no. Can price be negative? Probably not. Is category required? Maybe we put other. That way it has to be defined, and if you don't have a good one, then at least you have the other option, right? We want to be able to read a product, so get a specific product. That means by ID. We want to be able to get a list of products and search. So search criteria. We want to be able to search by name or description. We want to be able to search by category. And we want to be able to order by price or order by alphanumeric order. And we also want to be able to search by region. Again, we have US and Canada in our application. And I'm challenging you. I want you to specifically do this in the header. So in the header of the request, I want you to put either US or Canada, and then based on that, then you give a different response back. The business does not want you to send all of the data, so exclude the timestamps and the region. So you should be thinking, okay, DTO, data transfer object. And again, you don't need to send back the region, right? Because if you're searching by region and you say US, why would you send US back in the response? That would just be a waste of data. You could say the same thing for category, right? If you're searching by category, should you send category back in the response? I mean, you could choose to exclude it, or maybe it's not worth the development time. I mean, it's not that much data. So these are all questions you're going to have to think about and answer. The business really cares about performance with regards to get products. So that means caching. You're going to cache all of your get products endpoints. You don't need to cache anything else. They want the ability to create or update a product. And so you should be thinking about your get mappings, right? So you have get, you have post for create, you have put for update. Here's an interesting challenge. They don't want profanity or expletives to be added to their application. So we're going to use a third-party API, the Profanity Filter API. We're going to need an API key. If you don't know what that is, just Google it. Essentially, instead of it being completely open, you have to register to be able to use their API. It is free though, no credit card. You do need an email address to get this working. And this will be a good practice of external API integration, right? We want exception handling for bad data and sending messages back to the UI. So if you try to save something with an expletive, we need to send back a message, nope, can't save this, and prevent it from saving to the database. Same thing if you try to define a price that's negative. We need to send reasonable error messages back to the UI. Testing. The business wants a thoroughly tested application. Whatever that means. They always say shit like this, right? What that means is we're going to write unit tests, and we're going to write as many unit tests as reasonable. We're even going to try some TDD, test-driven development, where we write our unit tests first and then write the minimum amount of code to get there. So we're going to try that out. Logging. So this is really good for the long-term maintenance of the application. We're going to add logging to each endpoint to see what's coming into the endpoint, what errors are thrown, etc. The business wants this project to be database independent. They don't know if they're going to keep MySQL in the future. Maybe they switch to Postgres, maybe they switch to Microsoft SQL Server. If you don't know what I'm trying to say here, basically I'm saying don't write custom queries. So if you write a custom query, it has to be in a native language like MySQL or Postgres. But if you do find by ID, what you're doing is you're letting the ORM, like Hibernate, do it for you, and it generates the SQL statements. So what you could do, theoretically, is hot swap out your database from MySQL to Postgres without writing any new code. So that's what we're going to do. We're not going to write any custom queries. We're going to let the ORM do it for us. We're going to use the latest code standards and paradigms. They always say shit like this. I don't know what that means either. Just that's how business talks, right? And then lastly, once we're complete, we're going to add security. So only logged in users can create, update, or delete products. All users may get products. So we're not going to have any security on the get endpoints. Kind of like Amazon, right? Like you can go search for stuff on Amazon and look for stuff without being logged in. We're going to use JSON web tokens and the security filter chain to achieve this. And then we're also going to, and that also means we need to add access control. So role-based access control, etc. So try to go implement this on your own. And if you get stuck, you can come back. Friendly reminder, use ChatGPT to help you out. Use Gemini. And one other thing, off screen, when I'm coding, I have all of the code that already works and is tested and validated with notes and explanations. So the point I'm trying to make is these videos, for the purpose of these videos, I have everything ready. Off screen, I spent hours and hours debugging, setting it up the wrong way. The database didn't propagate the right way. I used the wrong annotation, like so much debugging, so much crap. And the point is, you're gonna go through that, and that's okay. Don't think that I have it all together either. Nobody does until you have years and years, a decade of experience, right? It's just not very helpful for me or for you for me to debug my code for 37 minutes on screen. So this is set up, a little easier. Okay, with that being said, I already have a project set up. So friendly reminder, you need to go to the Spring Initializer website. You need to download a zip file. You need to import it. You need to add all of your dependencies. You need to connect in the properties file, you need to connect it to your database with the username and password. In my SQL workbench, let me close this. I already created a database, final exam. So I ran the command, right? Create database, final exam. So a lot of background work went into this already. So definitely check out my first couple of videos to get you set up. Okay. And the first thing I did here is I just created a simple endpoint. I have a product controller. I don't even have a product yet, but I just have a simple get mapping of sanity check that returns a string. So let's go ahead and launch this. And sanity checks are really important. It just makes sure, like, is your project just baseline working? Are you sane? If you start coding all this crap and don't even test it, for 5 hours later, you're gonna have no idea why. So why things are broken. So let's go over to Postman, ping it. Okay, great. It's working. Okay, without further ado, let's get started. So, where shall we start? Let's start with the product endpoint, of course. So I'm going to create, I already have a new folder here, product. So I'm just going to move my product controller in there. And let's create a new entity class, new Java class, product. Oops, what happened? Okay, I don't know why I did that, but here we go. So of course we need to annotate it with that entity. Also, I also have it configured to automatically run my SQL queries. So that's what we covered in the most recent video, right? So I will not be, create table in SQL. It's going to do it for me. So at entity, I know eventually I'm going to need my getters and setters. So getter, setter. Okay, so what do we want to do for the ID? So we know we need an ID, and we know it's going to be private string ID, but is it going to be a string? Do we want an integer? Do we want UUID? The decision I've made is we're going to do a UUID, but we're going to save it as a string. So if you remember in the GUID video, we saved it as a UUID, which means in the database it came across as a blob, which is a pain in the butt, because when you go to your database and you're trying to see, which entity you're looking at, it's like all you see is blob and not the actual ID. And so when you try to search by ID, you have to deconstruct it from a blob to an integer. It's just a pain in the ass to save what, like a byte of data. So we're not doing that. But we are doing a GUID. We're just saving it as a string. So we're going to say at generated value. Our generator is going to be UUID. And you can look up the documentation for this. You can have a bunch of different types of generators. And we need to select a generic generator. Name is going to be UUID. Strategy is going to be, there's a lot of strategies. We're going to let Hibernate do it for us. Actually, I'm going to copy just to make sure I don't completely screw it up. And just FYI, I didn't know this off the top of my head. I had to go ask AI 3 times to get this answer, and I screwed up a few times building my database. So, this takes time to learn. Okay, so we needed a name. So column name is equal to name. Remember, the column annotation is actually unnecessary, but I like to include them. Private string name. We had a description, so at column name equals description, and we should properly space, right? private string description. Okay. We had a manufacturer, column, name is equal to manufacturer. Okay. We had a price, column, name is equal to price. And we're going to go big double price. Maybe we want it to be null, where they didn't define it. Who knows? So the next thing we need is category. Let's come back to that. We'll need to define another entity for category. Column name is equal to region. And we said we were going to do an enum for region. So let's do that. So file, new, Java class. Technically it's an enum. And it's going to be region. And US, Canada. Of course you can define custom strings. I think this should be fine. So private region, region. And I found out this the hard way. If you just leave it like this and you select US, it will save it to the database as 0 because it's the 0th index. And if you do Canada, it'll save it as 1 because it's index 1. Those are ordinal enums, super pain in the ass. So what we need to do is at enumerated enum type of string. That way when we save it to the database, it's actually a string. So this only exists in our Java code, not in the database, in the sense that there's no region entity. So you would have to fully deploy it with a new region, okay? I'm just going to copy paste these two. So these are super useful. So with these annotations, created at, updated at, creation timestamp, anytime we create a new entity and it assigns it an ID, it will automatically timestamp it and save it to the database. Anytime we update it, meaning like a put, and we update any value, it automatically updates this timestamp in the database. So this is super useful. We don't have to manage anything here. It just does it for us. So I strongly recommend looking up these annotations. They're super useful. Okay, let's define our category. So this will be the tricky one, right? This is our mapping. Category, okay. So at entity, we definitely need a getter. And I believe I needed, oops, an all args constructor, and I believe I needed a no args constructor. Okay. So category is interesting. What do we do here? We could have ID and the category name. You actually don't have to even do that. What you can do is just have the category is the primary key, right? Because we want a unique list and ID has to be unique in SQL, right? So what we're going to do is the ID is going to be the primary key, and it really can be that simple. So every entity needs an ID. Private string, what do we name it? I don't think category makes sense because it's already a category. So it's kind of like value, I think makes sense. Okay, coming back to our product, let's go ahead and define our category. So we have, let's do it first, private category. And then this is a many-to-one relationship. Many products can have one category. and then we have to join the table, right? I always have to look this up. I never remember how to do this. Name is equal to category underscore value. Actually, I'm just going to copy and make sure I don't screw it up. Okay, category value, and then it references the column name of value that we just defined. Okay. That should do it. A lot of really good annotations, and you guys should have learned some stuff, right? Creation timestamp. So if I run this, it should generate all of my tables in MySQL. And I've already generated them to make sure they're working, but I'll go ahead and boot it up anyway. Coming over to MySQL Workbench, if we describe product, we can see it was generated. So right there, because we define enum, what we're saying is it can only be Canada or US. That's really convenient. And where's our category? Category, we can see it references another table. So define category. And there you go. One column, and it's its own primary key. All right, good stuff. Let's create our repositories. So every entity needs a repository, right? New, Java class, should be an interface. So product repository. Of course, we annotate it with @repository. It extends the JPA repository. And this is where we have to be careful. So it should be the entity. The entity is product. And then the primary key is technically a string. Again, it's a UUID saved as a string, but technically it's being saved as a string. Let's do one more. New Java class, category repository. Oh, this is an interface. Sorry. Okay. I'm going to create a new folder just for category. I think we're good to go. Okay. So coming back to our product controller, let's just do 2 more sanity checks. We'll just return a list of all of our products. So private final product repository, and then we want the constructor. We're going to abstract this out into the service class in just a second. I just want to quickly make sure things are looking good here. Product repository, find all, and we will reboot. And while that's rebooting, I'll go ahead and create the category controller. Okay, technically I didn't define a response entity here, but let's see what happens. So here's my sanity check. Okay, it looks good. Obviously I have some dummy data already in there. You need to add that yourself, right? Using AI probably. And here we have category shoved into value. So when we make our DTL, I'm thinking of flattening this out, right? And we have our timestamps, different timestamps, because I updated this one and checked it, and we've got our ID that is a GUID. So this looks really good. Coming back to our category controller, get categories. Let's relaunch this and check this one. So what would you use this for, right? Get categories. Why would you want to just return all of the categories? Well, you know, on Amazon, there's plenty of times when there's a list of show me what category, and then you click on it and then you go to that specific section. So this is a good use case for that. So I'm going to say get categories, see what happens. There you go. So a list of values. This kind of sucks. I'd probably just return a list of strings, or maybe you do need a GUID. Oh, maybe that's a good use case for having a GUID, right? Anyway, another idea for another time. Okay, continuing on, we're going to abstract this query category repository into its service class. So, new Java class. We'll call it get category query handler. And we want to implement an interface. We're going to call it query, and it has input and output. It's going to have one method that you need to implement, response entity, with the output, and then you execute from the I input. All this does is enforce a contract and say, hey, you have to implement this method. So this will be a service class, and it will implement query. The input will be void, and the output will be a list, well, response entity of a list of actually, it should be a category DTL. So we need to create a category DTL. I'm thinking about how to implement this. But yeah, we'll do that in just a second. Okay. Coming back to our controller, we did have the repositories over here. They should not live over here. They should live here. Implement methods, go. And this is not the controller, this is the query handler. Okay. So we're going to return category repository dot find all. But we need to convert this into a DTO, right? So I'm just thinking about the structure here. I'm thinking about just a list of strings. And if we have a list of strings, do we need a DTO? I don't think so. Okay. So this is going to return a list of strings. So we can just do a quick mapping here. So category repository dot find all dot stream dot map. I never know how to do this right, so I always do it like this and have the IDE correct me. So lm dot get value, and then collect to list. And then, all right, return response entity dot OK. Boom. Boom. And then, okay. Now, see, this is highlighted in yellow. We talked about this in the linter section, right? So what I do is lambda can be replaced with method reference. So I just, come on. Replace. Okay, category : get value. So I never remember the syntax, so I just have it do it for me. Okay, I'm also looking at the little yellow lines here. Constructor is never used. Yeah, it is. It's dependency injection. Class never used. Okay, well, we're about to use it. Jeez. Sorry. Okay, so get. So this should be private final get category query handler, get category query handler. And then we need a constructor. Generate constructor. Boom. And then we're going to return. It should return a list of strings now. Get category query handler dot execute, and it doesn't need anything, so we just pass in null. Okay, what's your problem? Oh, is this too many response entities? Of course, of course. Incompatible return type. So try this. Okay, are we all happy now? Do we compile? Nope. I love the Java compiler. It is so helpful. Off we go. Okay, let me get my categories. Okay, I'm already up. So before it was returning these object type things, which I did not want. I wanted just a list of strings. So let's hit send now. Yeah, perfect, perfect. Okay, and I already put two categories in there. Okay, we need a couple more things. We need unit tests and we need logging. So let's do the logging first. Private final logger is equal to logger factory dot get logger, and then I just pass in the class name. And then we just log something sensible. So logger.info. It's not an error, so just info should be fine. I kind of already wrote one, but something like this. Now, if we really wanted to, we could log the entire response here, and maybe that would be helpful. I'm not going to do that here, but something to think about. Okay, let's make some unit tests. The most fun thing about a developer. New Java class. Get category query handler test. Okay, remember there's a lot of crap we got to do here. Okay, first we have to annotate it with where to scan. So at spring boot test classes is equal to final exam application tests dot class. We then need to mock private category repository and then private get category query handler, get category query handler. We're going to write a couple of unit tests. So we actually want to do something before each unit test. So you can do, I don't remember if we covered this, but you can do a before each. So this runs before each unit test. So void, it's often called setup. And we just want to instantiate this. So get category query handler is equal to new get category query handler, and we pass in the repository. So this will run before each unit test. I have two tests I want to write. One's going to be returns empty list, and one's going to be return an actual real list of categories. So all tests return void category query handler underscore returns list. Something like that, right? So let's set up what our expected is. So list of category category list is equal to arrays dot as list, and then we'll say new category. Okay. So electronics bathroom automobile. Okay. So then we do when category repository, and we set up the response. So find all. Then return categories. Then we say list of string expected is equal to arrays as list. So we don't want it to return a list of categories, we want it to return a list of strings, right? That's what we're expecting. It's then going to return a response entity with a list of strings. Actual is equal to, and then we run it through. Execute, we pass in null. We then want to assert equals. Expected and actual. Okay. Now what I like to do is I like to purposely make it fail to make sure it fails in the correct way. So if I do something like this, you can then click run. And it failed, which is good. Electronics, bathroom, automobile 1, electronics, bathroom, automobile. So this is exactly what we wanted it to do, wanted it to fail. And actually it should be response entity. So it should be response entity dot okay with a body of expected. That's what it should have been. So let's run it again. Okay, still failed. There we go. It looks identical now with the exception of R1. So let's remove this. And this is a good sanity check. You want it to fail until you change it to exactly the right thing. Otherwise, you might have set something up incorrectly. Great, green check mark. Remember, you can also go to the terminal and type in mvn test or maven test, and it'll run all your tests. Or you can come over here and do test and do run tests in com example demo. And there you go. Actually, it's still running. There's another test. So it also came with another unit test of context loads. And that's just another sanity check, right? It didn't actually assert anything. It just kind of makes sure that your project is actually running. So we have 2 test pass, 2 of 2, which is good. Okay, we're going to have one more test. This is going to be empty list. So at test return void, category query handler returns empty list. So when category repository dot find all, then return collections dot, and we want this one. My boss told me to use this one. I don't know why. Okay. We then need to get the actual. So response entity list of string actual is, and then we run it through get category query handler dot execute. And then we want to assert equals response entity dot OK, and we pass in we're expecting collections dot empty list, and then the actual is actual. So this should pass. Let's go ahead and run it. I do want to make sure, I do want to force it to fail though, to make sure that it's the correct setup. Okay, it passed. Let's force it to fail. So we say collections singleton list new category of, I don't know, TVs. And we want this to fail. Hopefully this fails. Okay, it failed. There you go. Great. So we're going to say collections dot empty list. And anytime you change something, you need to rerun it. See, imagine if we pushed that. I'd be in major trouble for breaking the build. And actually, we want to run all of our unit tests. So I'm just going to click run all tests. Okay, everything ran correctly here, and it's still doing the context load, which is kind of a waste of time. But yeah, this looks good. So we have unit tests for our query handler. So in this case, we did it the normal way, quote unquote, the normal way, where we developed code and then we came back and added unit tests. In the future, we're going to try to invert that and do test-driven development where we write the unit tests first. Okay, continuing on our mission. Let's do the delete mapping. This one will be a little bit simpler, relatively, right? So we're going to delete a product by its ID. So at delete mapping slash delete slash ID. Then if you remember, this is a path variable. So at path variable, string of ID, which is our GUID. We then need our delete product command handler, and we also need to implement our command. So we implemented our interface of query to enforce a contract. We're going to do the same thing, but with command. So there's input, there's output, and it's going to have one method, returns a response entity with the output, execute, I input. Oh, it's an interface. Okay, that will enforce our contract. Great. Okay. We then need a product delete handler. So delete product command handler. So if you remember, command means we're mutating the state of the database, whereas query means we're just getting information from the database and not changing the state of the database. So that's why we called it command, even though it does basically the same thing in terms of Java code setup anyway. So of course we annotate this with @service. And if you remember, @service has the component annotation. So this gets instantiated and shoved in the Spring container. It's going to implement our command. And our input is string, and our output is void. And implement the methods. Great. So the input is actually an ID. Okay, let's just link it up here. So we've got a private final delete product command handler, delete product command handler, and we need to set it in our constructor. And then we should be able to return execute ID. Okay, our controller is now set up. We have a lot of work to do in here. Before we get started, let's do some test-driven development. So let's try to write our unit tests first before we write our code. We're not going to be able to fully do it, and you'll see why, but we'll give it a try. So coming down to our tests. So first, let's move some stuff around. Get category query handler test. We're going to put that in a folder of category. There is a conflict, and I know what it is. If you come in here, it's not able to find this class. So we're just going to make this public. So all that did is it made this public right here. Okay. So just to be safe, let's run all our tests while we're doing other stuff. So in our product folder, we'll write a new test class, new Java class, delete product command handler test. And that's really spinning up, isn't it? So we'll need the same thing. This tells it where to load. Good, all of our unit tests work, so even though we move some stuff around, we are still good to go. Good. Let's do some side-by-side action. Okay. We are going to need a mock of private product repository. And then we need a private delete product command handler. Delete product command handler. And then we need to instantiate it. So before each test runs, we're going to do some setup. And then our delete product command handler is going to equal to new delete product command handler. And we pass in the product repository. And we don't have a constructor yet, do we? No, we don't. Okay. So we need a product repository. And let's generate our constructor. Okay. And now this is happy. Okay. So I can think of two tests. So test one is delete successfully. And test two is product not found and send message to UI. So we do at test. Let's do the first one first. So void delete product command handler returns success. So we need a product and we need it to have an ID. So string ID is equal to just ID of 1 should be fine. Product equals new product. And then we'll set the ID to the ID we just created. I could do something fancier here with a constructor, but Okay, we've got our static method. Okay, so when our product repository dot find by ID, and we pass in that ID, then we want it to return an optional of product. And let's make this full size. Okay. So this is setting up our prerequisite state. And then we want it to actually run through the thing. So delete product command handler dot execute. We pass in the ID. Well, what does this return? This returns a response entity. So response entity is equal to, great. We then want to verify a couple of things. So let's assert equals we're going to assert that the response entity dot get status code is equal to HTTP status of OK. But we also want to verify that it deleted it from the database. So remember, we don't actually verify that it deleted from the database. We're mocking all of this. So what we do is we say verify that the product repository, the delete method was called on the product entity. So this verifies that the delete method was called on this product entity. You can also do other things like verify how many times the product repository was accessed, but this should be good. Okay, so this unit test should fail. So if we run this, okay, it failed. And why did it fail? Wanted but not invoked. So the very first assertion failed. This was never invoked, the delete call. Okay, which is good. This should fail. So now what we're going to do is we're going to do the minimum amount of code required to get this to pass. That's the idea of test-driven development. So coming back to our delete product query handler, command handler, we are going to, so what we want to do is we want to do product repository dot delete, and then we do product repository. Well, let's do it. We could just pass in the ID here, or the product, but we're going to do it a little bit differently. We're going to say optional of product. I always just call it optional product. It's equal to product repository dot find by ID. We pass in the ID. So if optional product dot is empty, we're going to do something else. Now we're not there yet, right? We've got to do our test-driven development. But so we'll say to do. Otherwise, we want to call delete on the product entity. So our optional product dot get. We're then going to return response entity dot OK dot build. Okay, so this calls the delete, and then it checks the, or then it sends the response entity. So this unit test should now pass, I think. And there we go. Our unit test passed. So there you go, test-driven development. Okay. So our next test is going to be throws product not found exception. So we don't even have a product not found exception to be thrown yet, but we can still get started at something. So we're going to do something similar up here. No need to reinvent the wheel. So we got our product. Okay, so when product repository dot find by ID of ID, then return optional dot empty. So it returns nothing, right? Then we want it to throw a product not found exception. So product not found exception is equal to, we want to assert that this was thrown. Assert throws product not found exception dot class. Nice little lambda function. Delete product command handler dot execute, and we pass in the ID. So I'll enter here so you guys can see it. Okay, and we don't have product not found exception, at least not yet. We want to assert equals that the message sent was product not found. So product not found, and then we're going to say exception dot, and well, we've got to implement all this, right? So get simple response dot get message. So this is why test-driven development can be really difficult, because this isn't implemented, and what if you made a spelling mistake or whatnot, and now you can't even run your tests. So, but that's just how things go. So I created a folder called exceptions. So we're going to do new Java class product not found exception. And previously what we did is we extended a custom base exception. So let's do that. Custom base exception. And this extends runtime exception. Okay. And for now, we just had two things in there. So a private HTTP status of status. Import, please. And a private simple response. This is our custom response that we did. You don't have to do it this way exactly, but that's the way I did it. So then we need a simple response. And all our simple response had was need an all args constructor, and we need a getter. Oops. And all it had was a private string of message. So making our way back up, okay, we got simple response. So our custom base exception, what did it need? It needed a getter. Well, it needed an all args constructor and a getter. Okay. Then our product not found exception, that extends the custom base exception. And then we gotta implement the super constructor. Okay. And the way I did this is I didn't pass anything in. Because it's a product not found exception, I wanted it to be standardized. So I didn't even pass anything in here. What I did was HTTP status not found. And then, so you can just pass in your error message now. I like to have all of my error messages in one place. So I'm going to define an enum for the error message. So there's a lot of complexity here. So enum, we're going to say error message. So we're going to have product not found, and it will say product not found, well, lowercase. But we also want a way to not just get this, but get the actual message. So we need a private final string message. We need a constructor where we pass in the message, and this dot message is equal to message. And we just need a getter. So public string get message return message. So I like to have enums for this. That way you can see all the error messages all in one place. So this will be a giant list at some point, right? So we say error message dot product not found dot get message. And that way when the business comes back and says, I want an exclamation mark, you only have one place to change it. What's the problem? You're not happy? Oh, this needs to be a simple response. So new simple response, and then we pass in the string. Okay. At this point, we should be able to import. Great. Okay, there's our simple response and our get message. Okay, so now we need to actually implement the code. So this unit test should still fail. It should actually run now because it'll compile, but it should fail. Okay. So instead of throwing a product not found exception, we got a no such element exception. Okay. So good. This failed exactly how we expected it to. Okay. So if optional product is empty, then we want to throw new product not found exception. Okay, let's try to run our test again. Minimum amount of code needed to get this test to pass. And it passed. There you go. So that's test-driven development. It's kind of difficult the first time around because you have to know exactly what you're doing. I think TDD makes sense when you've already done it 100 times and you're just doing it for the 101st time. It's really hard the first time you do it because you don't even know what you're trying to do. Okay. Did we do an exception handler? No, we did not. Okay, so this worked, but what we want is to handle all of our exceptions all in one place, and I don't think we did that. No, we did not. Okay, so new Java class. So if you remember, we had a global exception handler, and it was annotated with that controller advice. And we say exception handler, public response entity, and it's going to be a simple response, handle exception, and it's going to be a custom base exception, and everything that inherits this or extends this, return response entity dot status. So exception.getStatus when we create it, and our body is going to be body exception.getSimpleResponse. Okay. So let's run all of our unit tests. They should all pass. So the two we just wrote passed, and everything passed. Okay, good. So we didn't screw anything up by adding this. Now we need to do real-life testing to see if it actually works. So let's boot up our whole application. We've already got an endpoint defined in Postman, so it's just delete and then your GUID. Let's pass in one that doesn't exist. Great, product not found. Remember, the first time you ping something, it takes a second to kind of load up, right? So 28 milliseconds. Let's try it one more time. Boom, 19 milliseconds, so it's faster. Okay. Going into MySQL Workbench, let's find an actual GUID. So, okay, here's a product we can delete. Let's copy. Okay, and we got a 200 status. We did not program any message to come back. We just said, okay. So if we come over here and check the database, it has been deleted. Okay, so we did our unit tests and we did our actual legit testing to make sure it works. You got to do both. And off screen, I added some logging statements. So as you can see, we have a logging statement for anytime we enter the product command handler, along with the ID and the class name. And then I also added one more in our product not found exception. So anytime a product not found exception is thrown, we log it as well. And I did log error. Okay, see you in the next video.